Hey everybody! I am comfy and ready to teach. I hope that you are equally as comfy and ready to learn. Alright, so we're going to start our study of confidence intervals. Confidence intervals is like the first part of inferential statistics, and inferential statistics let us infer like you learn something about the sample and then you can apply it to the population. And so one of those things is confidence intervals. Then we're going to learn about confidence intervals, how confident we are about different uh, aspects of the sample to the population. All right, so this should say estimator. Or an estimator. Okay, estimating, right? You just you're estimating the parameter, okay, from the sample statistic. So like if we asked 100 people what they spent on Valentine's Day and the average was 126, we might just say that it was $126 for everybody. All right, so when we do inferential stats, there's some natural assumptions. The samples are random. It's greater than 30. If it's less than 30, it's normally distributed. All right, remember, parameter relates to the population, statistics relates to the sample, and so just like right here, if we asked 1,000 people, I know I said 100 before, but if we had 1,000 people, what they spent on Valentine's Day, and they said 126, then we would say that's the statistic of the sample, and then the parameter of the population would also be 126. Right, there's three properties of a good estimator. It's unbiased, it's consistent, and it's relatively efficient. All right, so unbiased means that the approximate value of the estimator from the sample is equal to the parameter in the population. Consistent means as your sample size increases, the estimator in the sample approaches the parameter in the population. And relatively efficient means that it's the best statistic. So different statistics could be mean, it could be mode, it could be standard deviation, it could be variance, it could be median. Okay, the one that we use the most often is the mean, but it depends on the type of data. If we had categories, we would use the mode. If we had pure numbers, we would use the mean. And so for it to be relatively efficient, it has the smallest variance, which is why we calculate standard deviation and variance. All right, a point estimate is just a specific numerical value. So the best one is the mean. It varies less than the median and the mode. And it's going to be somewhat different than the population because of sampling error. I'll review that in a minute. Right, sorry, I wanted to turn my phone off. All right, so a point estimate is just a single value. In this class, we're going to mainly deal with the mean, the average. So for example, we have some data. A social networking website allows users to add friends and messages, profiles, blah, blah, blah. The following represents a random sample of friends for 40 users. Find the point estimate of the population mean. All right, so we need to find the mean of this data. And we can do that one of two ways. We can add them all up and divide by 40, or what I'm going to do is I'm going to put it, there you go. Okay, I'm going to put it in my list. And so to get that list, I did that, edit, then I went to list. All right, so I'm going to type it in really quick. Hope you're typing it with me. Hope you're doing this with me. We're almost done. All right, one of the benefits to putting it in a list versus you just finding the average of all these, you could also use Excel if you know how to do that, is that we're going to, like, what if we need this data again? Then we'll have to go back through and find it all by hand. All right, so I put it in, here we go, my list. I'm going to go to stat, calculate one variable statistics. Okay, and then I'm going to make sure, I put mine in list 1. If yours is in list 1, put L1, and so there's my data. We've done that before. I'm just going to focus on the mean, 125.3 is the average number of friends. So this would be the point estimate. Okay, and it tells you what kind of point estimate it wants. All right, so an interval estimate is you want to know with, like, when they give out, like, the president approval ratings, they'll say, like, oh, they approve of him 65%, give or take 3%. And so that give or take is an interval. And so if it was 65%, then you would subtract 3, so it's 62. And if it was 65%, you add 3, it's 68. I'm going to go into the depths of this later. I'm just kind of pointing out that we have an interval estimate. All right, so the sampling error is the difference between the sample, like in the mean, and the population. Okay, and so that often happens, like if you have, like, your sample is too small, like, or if you notice as you go, as your sample increases, like 100 versus 1,000 versus 5,000, that will get closer to the actual population number. All right, and so since we can't know for sure about our point estimate, like when we did the Facebook friends up there, that was only 40 people, and there's millions of people on Facebook, so that would not be a great way to estimate the average number of friends. And so you use an interval estimate and a level of confidence. Okay, and so I sometimes it's called level of confidence, sometimes it's called confidence interval, which is the I. All right, so interval estimate, this is us going into it, is a range of values to estimate the population parameter, like the number in the population. All right, so for example, you could say the average age of students is between 21.9 and 22.7, or this guy right here is mean, the mu, and you could say it's 22.3, give or take 0.4 years. All right, and so when you have an interval estimate like that, you also have what's called a degree of confidence, or your confidence interval, or your level of confidence. And so you might say like, okay, the average age is 23.4, 22.3, give or take. Give or take 0.4 years, and I'm 99% confident in this. Or you could say, you know, it's 19.8, give or take 0.1 years, and I'm 90% confident. All right, so we have our common confidence intervals are 90, 95, and 99. We're going to use them all the time, and so you'll eventually just memorize them. Okay, I'm going to come back to those. I will need to explain some more vocabulary. This section is kind of vocabulary heavy, so that when I'm talking about it more, you aren't just like totally blindsided, like, oh my god, what's she talking about? All right, so you're going to see this thing. That one's called alpha, right there. Then we have alpha over 2. It's this whole thing. And then we have z alpha over 2. Z alpha over 2, it's with the z now. All right, so alpha means area. Alpha over 2, so there's our curve. And we have some z-scores right there. The mean is somewhere right there in the middle. Sure, we'll call that the middle. All right, and so this area right here and that area, like this curve. I am like totally rocking that. So that area, both of those areas combined is called alpha, and then just one of those areas is called alpha over 2. The critical point, the z alpha over 2, is that guy. So basically, it's the z-score, okay? Like, it's the estimated z-score. So this formula, I want you to notice something between these two formulas. So z alpha over 2, z alpha over 2, z alpha over 2. Then we have standard deviation, sigma, standard deviation, sigma. And we have square root of n, so that's the number of items in the sample. All right, this piece, z alpha over 2, sigma over square root of n, that's called the margin of error. All right, so that piece is called the margin of error. This piece. And so you can write the interval as a margin of error. Or you can write the interval as like an actual interval. And so we still have our sample mean, and then we're using it to estimate the population mean. Okay, and it looks like a crazy formula, but that same basic format for that formula, we're going to use 3 different formulas, but the setup is the exact same. All right, so the central limit theorem, which is what we talked about, says that when the sample size is large, 95% of it is within plus or minus 1.96. So remember we did this guy? Oh god. Where did we go back? Come on. We did this guy. And the center, and then one standard deviation was 65. 2 standard deviations was 95. 3 standard deviations was 99.7. And so that's where they get that number. It's not exactly when we learn these things, but it's rounded. All right, so the central limit theorem says 95% of the data is within plus or minus 1.96. 90% is within plus or minus 1.65, and 99% is within plus or minus 2.53. Remember, 3 standard deviations is 99.7. All right, so another way is we have these formulas. And notice something about these formulas. They're all basically the same formula. What changed here was that little piece. All right, and so we're going to talk about that more in the next video.